Dream. Super excited to be here with the SoraChain team. I think we can kick it off with a brief round of introductions. I'll just go really briefly for myself. My name is Vignesh. I'm the general manager for the EigenCompute team, and we've been working with the SoraChain team, I think, for a few months now on the compute integration. Uh, Frankie, why don't you go ahead and kick it off?
Sure thing. So, hi, this is Frankie. So, I'm one of the co-founders of SoraChain AI. So, I mainly take care of the technical part. So, I'm the CTO on at SoraChain AI. Yeah.
Yeah, and this is why I'm here, mainly taking care about all the business and ecosystem stuff. We've been operating almost a year now. We have been into R&D. It has been awesome to work with EigenCompute and in general EigenLayer stack. Like it has really helped us to speed up what we have been doing. So yeah, happy to uh, talk about it.
Yeah, awesome, and so glad for you guys to be here. Why don't we actually just start talking a little bit about SoraChain? What was the problem that you're trying to solve, and why was like maybe the centralized infrastructure or a Web 2 style build out not going to solve that problem for you?
Yeah, so there are two big problems that we are solving. The first is access to high quality data, which is perhaps not really available in other ways. And other big vertical that is collaborative AI training at scale without giving away the data. So data stays where it is. So the core problem here is like if you just take AI training stack, you collect the data, you aggregate it, you clean it, and give it to the model for training. The problem is aggregation, like especially in sensitive domains, you cannot really aggregate the data. This could be healthcare or life science or even your personal data that cannot be aggregated. And intuitive is like, why not just use cloud infrastructure to do it? But as soon as you try to use cloud, the biggest question is data sovereignty. Like because your sensitive data is moving across the border, and as soon as it tries to move cross borders, the accountability disappears and the compliance risk explodes. And that's the reason we need a trustless infrastructure to coordinate this, in which, let's say, hospital A in US has some data, wants to collaborate with hospital B in Japan to train on the same data set. They don't have to trust each other. They can just train with each other on the central model. And this is where we use federated learning to make this happen.
Yeah, that makes a
And
lot of
we,
sense.
and
Yeah,
we as
sorry,
an
go.
infrastructure orchestrate and coordinate the entire training process, where anyone could launch their own dedicated network to for a vertical specific model.
Yeah, that makes a ton of sense to me. I mean, I think even just on a personal level, like I, did the 23andMe DNA, and I have, I have no idea who has access or what
Yeah,
happened to that data,
exactly.
right?
Yeah.
Yeah, yeah, exactly.
And
Because it's on cloud, right? Like someone has stored it, uh, have it on some cloud infrastructure, and then it was the company was sold to someone or somewhere, and we have no clue. The core essence of what we are doing with federated learning is the data stays where it is, and only the intelligence is being shared upon or worked upon. And data, raw data is never shared. There is no data movement. Data stays in your premise or on your device.
yeah, that makes a lot of sense. And I know one of the big things with like AI and ML in general is just the access the model has to train, the data access it has, right?
Mhm.
And if you unlock new ways to have new types of data, um,
Exactly.
you can get much more powerful
Yeah.
outputs, right?
Yeah. So I think one a good example that we often talk about is Swift, which is the global payment railway. They
Mhm.
move like 7.5 trillion day in, day out. And still they went and yet their own data is not enough to build a good robust fraud detection model, and they went on to do a federated learning consortium with other banks, in which they are trying to build a network of other banks who are also contributing to the same model for the training, because the core here is data diversity and how you get the underrepresented data into the training such that your model could actually be useful.
Yeah, and that makes a lot of sense. Like basically, like they have like a shared goal. They want to like have
Yeah,
more secure fraud detection,
yeah,
but they
exactly.
probably don't want to give up all their business data as
Yeah,
well, right? Because then you can
yeah,
kind of know a lot of business intelligence, which might wouldn't be bad for your business.
And it's
right?
not just about competitive advantage, it's also just a compliance, right? Like because of different countries' jurisdictions, you are not allowed to share that data. Even with your competitor, even you cannot train on that data or aggregate that data. So like all those problems, like but if your entity, you can actually train your own model internally. There are no restrictions on that part. And that's what most of them do, but their own data is limited to do a good model. So what we
Yeah.
enable is for them to collaborate globally without having to trust someone. That's simply how Ethereum or Bitcoin works. Right? Like you don't really, if you're joining a new node or starting up a new node on Bitcoin, you don't have to trust the rest of the network, and the rest of the network does not have to trust you. You are
Right.
just part
And
of it.
here you can contribute data. You don't have to trust anyone, and you
Yeah,
can help train the model and get some outputs, right?
yeah.
Awesome. Let's dive a little bit more into the promise. So like how does SoraChain keep the data, in a secure, like locked away environment and guarantee that you don't have to trust anyone?
Yeah, so it's quite simple. So we use federated learning, and this is a stack. Like there are a lot of open source good frameworks. One is from NVIDIA called NVFlair, and we use for our early experimentation. We have relied on NVIDIA Flare so far, and at the very core, the data stays where it is. Like that's the essence of how the entire training process works. The model comes to the data rather than data going to the model. So the raw data is never shared. The model comes to the data. The training happens locally, and yeah, and then you just share the weights and gradients to the global model. Now this could be even encrypted, and this is exactly where EigenCompute comes in, where we can, for some use cases, let's say healthcare, life science, or wherever the data is super critical and sensitive, we can use one more layer of security, which is running Ts to do the aggregations and to run the model or even for the inference part. So this is where like that our stack is more modular. Like we can use any privacy enabled technologies there.
Right. Yeah, and that makes sense. And I think with the EigenCompute T stuff, like there's also this guarantee that no one can update the code and like steal all the data or anything like that, right? Which is also
Yeah,
probably pretty powerful for some of your
yeah,
scenarios.
Yeah.
exactly. So it's like a double level guarantee, right? Like we are already providing you with like differential privacy, which is baked in into how federated learning works. But on top of that, you're coupling with, let's say, EigenCompute or verifiable inference, in which you can actually know all. It's not a black box then. If you
Right.
want to verify, you can. Yeah.
No, that makes a ton of sense. Maybe you can just like talk a little bit more about how you guys, picked EigenCompute for these workloads and what made it a good choice for your scenarios.
Right. So, there are a lot of, I would say, challenges or I would say verticals that we were eyeing on while building our framework. So I would just list few of them. Like, we had in sort of inbuilt security of, just transferring weights and gradients and using differential privacy to send those gradients to aggregation and, build a supermodel. But sometimes what happens is that some enterprises, some healthcare, some life sciences needs more secured privacy. So since EigenCompute has inbuilt hardware-backed security provided by TDXNT, so it adds a point of trust, more trust while working with these enterprises and building more robust framework. Second is like the developer experience. So we are building a framework which can be used by independent developers to spin off their own kind of a network to run or train model for specific use cases. So we wanted developer experience to be very quick, easy to use, fast deploymentation, good documentation, active support. And when we were working with EigenCompute, it was just we used Eigen CLI, and it was quick deployment plus on-chain integration. You need not to do any sort of key management. It's like automatic key management plus aggregation. When it comes to aggregation, we can ensure that our aggregated model stays intact without any malicious activity being going on. So all these factors actually we thought of, and then we said, okay, let's use EigenCompute. I think this is one of the best verified aggregation method or platform that we can utilize. And that's how we use EigenCompute in our framework.
That's awesome. Actually, would also love to know how we can make EigenCompute better. Any other features, anything we could have done to make your life a little bit easier in that process?
Right. Yes, a couple of feedbacks that I gave to the team is from the logging perspective. If we can make the logs of what all so since we were doing some sort of training inside TE, and we needed good logs as well. What is happening? So maybe some sort of logging dashboard or something real time. It could have we can get. It'll be very good in the development stage specifically. But otherwise, look, TE worked really well. The iteration was super smooth. So I mentioned that the things which used to take couple of weeks, the time actually reduced from just 1 or 2 days. It was just very fast deployment. We don't have to manage on-chain integration and take the hassle of deploying our own TEs, custom TE. So it was just very smooth on top of it.
That's awesome. Glad to hear it. And yeah, I think we'll have to, especially for development, I think logs make a ton of sense. So that's just really awesome feedback. How do you guys leverage kind of like the TDX and the TE attestations in your architecture in terms of like proving and like trust for the end users and the data sovereignty?
Right. So I would just split it into two parts. One is from the training side and one is from the inference side. So in the training side, we have different trainer nodes which have been deployed in multiple, I would say, locations or multiple nodes, which are training independently on their own private data and creating or generating their own weights and gradients of the model. So this is the first case wherein we ensure that whatever training is being happening with quality data is happening correctly. With no malicious activity that is being happening while training on the data. And then the gradients gets transferred to an aggregator node, which is also deployed in the TE. So we also ensure that whatever the final output of the global model, which is building up, is actually free from any sort of malicious activity. And then the on-chain integration, which logs all sort of activities that has been happened in the TE. So this is how on the first side we integrated TE, and the second is in the inference side. So since we can ensure that our models are deployed in TE and in a very secured enclave, and we are also providing our own private quality data. So we need to ensure that that data stays intact and does not go out of the box or does not gets leaked to the public cloud. So from the inference side, we also ensure that we have the trusted environment enclave security of EigenCompute. So these are the two ways which we utilize, the TE part.
Awesome. Yeah, it's very, very helpful explanation. Maybe like just for kind of like the AI folks in the audience, like kind of what is your like, how did you guys design the ML pipeline? How did you guys like set it up to like give like really powerful signals and outputs? Because I mean that's another big part of this, right? Like obviously like the data and the trust needs to be guaranteed, but we need to get the training models and everything set up in a way that's really going to provide better results through the federated learning and stuff on this type of data. So how have you guys been kind of like working to solve some of those aspects of the problem?
Right. So I would just give you a high-level overview of the pipeline, which we were working on. So our core goal is that if any person or any existing project that has been built using ML pipeline, we just directly onboard them. So if any existing project is built using Hugging Face pipeline or any TensorFlow or any Python open source project that has been built or it is existing. So we design the pipeline in such a manner that it's just a few lines of code and it gets automatically converted into the FL pipeline. So it's just like plug and play compute components that we have built. So you have the existing ML application. Then there is SoraChain engine, which has few lines of code. So you bring that open source or your existing project, write few lines of code. it is now in sync with the Sora engine. So all the execution of like training nodes, aggregation nodes, blockchain component, encryption technologies, anything like differential privacy or fully homomorphic encryption or any other that you want to utilize, it is there in the Sora engine. It can easily get hooked up inside the whole project. And then we have the blockchain component, which is again integrated with Sora engine. So with just few lines of code, you can just spin off your own network, and all the on-chain activity starts all together. So it's like existing project, then you have Sora engine, then you have blockchain. So all three working synchronously, and making sure the AI training model, AI training happens in a very private, secured environment, and by leveraging the EigenCompute, of course.
That's awesome. I think the next thing I would like to know is like, how do you guys build so fast? Like, I think we've observed that you guys like have been able to like prototype to production in just a couple of weeks. Like, what's your kind of like, how do you approach engineering? How do you move so fast?
Right. So earlier we were experimenting with many cloud-based platforms like AWS and Azure, and there are a lot of I would say activities that has to be done in order to ensure that, since we have a federated learning framework that works asynchronously, plus we are pushing onto the cloud and utilizing that platform. So there was a lot of sense of security aspect that we have to ensure does not get leaks. And also, we were also thinking of integrating our platform with TE as well. So there are a lot of manual works, checking on their SDKs, doing experimentation during the development life cycle. So the time that is being required to, from the ideation of what specific use case that we want to train, to actually deploy the whole project in a secured environment for the inference was, if let's suppose it was 2 weeks, then probably we use EigenCompute, and we saw that we already have the CLI deployment, and we already have the blockchain automatic key integration. So it just dropped to like just a 1 day or 2 day. So with just all sort of testing and iteration and everything. So that's how fast it became. And plus the reliability is of course like very high. So it's a kind of, so we got 100% uptime in our testing during a month long testing as well. So for, to be honest, for us it was the go-to platform for fast iteration. And since it's in the AI age, we need to be fast, and we were pretty fast in deploying using EigenCompute.
Yeah. Well, it's awesome to hear. And like, how big is your guys' team? Like, how many is it? Yeah.
Yeah, so we are 4 people currently. We are the 2 co-founders, and we are 2 developers who have been contributing with us. And we are expanding on at least one more person on the non-technical side. But so far, we have been really efficient with what we have.
Awesome. Yeah. I can see you guys move pretty fast with a pretty small team.
Yeah.
So it's awesome to see that.
Yeah.
What maybe like, how have you, what like metrics and things like model quality, uptime, I think you've already jumped into this, like what are some of the real world metrics and measurements that you've used to like validate your system and
Right.
prove it out?
All right. So we focused on few of the matrices, like what is the actual training time that is happening with the same data set while running on the personal device or in the cloud versus while running in the TE. What is the convergence time that we are getting, while working with cloud and TE? What is the inference latency? And specifically to various use cases, we did benchmarking. So all in all, just to give it just, while working with FL and TEE, we are at par with all sort of convergence and all sort of matrices that we achieved using a centralized training environment. And this is a good thing because when we are working with closed data silos like healthcare, like finance and research, even if like the time of training is, let's suppose, 1% or 2% high, but if the quality and the output and the privacy that is being needed is achieved, that makes a lot of sense, and a lot of commendable things or output come out of the work. So that is what really important is.
That's that's awesome to hear. Um, um, so one thing I'd love to know a little bit more about is like in terms of like customers or specific use cases that you guys are really excited about. Like, are there any customers or any use cases that you guys are seeing a lot of traction on your side and that you're really excited to kind of like enable with the new architecture?
Yeah, so I think one of the foremost things we have been excited for this project has been with healthcare and life science. But in essence, to do a GTM with this is bit, yeah, it's not that easy because it's really restricted industry, and to even experiment there requires a lot of different compliances and walkthroughs to even do a pilot with them. But one of the core thing that we are super excited these days is about personalized intelligence. So think about running your own model on your own device, and this could be something that we have been doing or when exploring a pilot with a partner is on a gaming platform on esports. So imagine they host global competitions, and there are like some top-notch players playing in their competitions. After the game, they want a personalized analysis on their gaming stats, like what could have they done well, and like what were the misses, what could be the improvement, and this is personalized, right? For my each game I want this to be personalized, and this is something that we have been exploring how we can make this happen. And this is the same framework, everything is same, it's just the model and the nature of data changes here. It's like each gamer who is in the live game stream runs the same model. Like they're on their own, let's say globally distributed wherever they are. On their own PC, they are running this model for the personalized analysis of the game. And as soon as after the game, they exactly know where they could have done better and how the other players who probably won the game did better and where they can improve. And this is something that is evolving, but this is really personalized. Like how, like what was your, yeah, skills and probably reaction time.
Yeah, that makes a ton of sense. Have you guys thought about other use cases with like personal data, like even just uploading your own personal data? Like, I don't know, you upload some pictures you've taken, you get
Yeah,
feedback on like how to be a better photographer. You don't want to share that with OpenAI because then it's gonna
yeah,
like
it's for
train.
everything, right? So
Yeah.
one of the things of a good point to mention here would be how we are complementary to these big models like you would say
Uh-huh.
GPT or Anthropic. Is like if you go to GPT today and ask a simple question like what should I do today here in, I don't know, in Dubai, and it probably does not really have context on where you are, what you are doing, and probably what's your agenda. So like it really misses your local context, or it really does not understand you. And this is exactly where we are building this model in which there's a localization and personalization, in which the model really learns about you as a person. And think about it like your co-pilot that really learns everything about you on your device. That is perhaps your conversations, health, wealth, life, everything around that, all different verticals. And something that could really give the bigger model some context on what you are exactly looking for, and something that works for you along with the bigger models. Bigger models are not trained on that data. Like you can do RAG and you can probably give it more, that's a PDFs and stuff, but it is still too passive. It's not actively even recommending you anything in the future because it's not trained on that data.
Yeah. No, that makes
Also,
a lot of
like,
sense. Yeah.
one more use case maybe I can add on top of it. So like we just out of just curiosity, we just created one project which we call social media influencer board. So since there are a lot of social media influences, everybody active on Instagram, on Facebook, on X, and everywhere. Now let's suppose if somebody has want to post something and wanted a really good lifelike caption which is trendy and also aligns with the tone of the influencer, which he or she in everyday use cases pushes or posts. So we took hundreds and thousands of social media influencers data and trained it using trained in our pipeline. And let's suppose, and then if I'm the one, I took out my personal private Instagram data. My account is of course private, it's not available to the public, but I have my access to my private data. I took out my private data, give it to my model training, and asked it, hey, give me a good caption which resonates with my tone, how I post on social media, because I don't want to give away my photo directly to ChatGPT, because it might get, it can go hayway there in the cloud and can get leaked at later stage. While I just wanted to get a recommendation about my photo which I want to post on social media or Instagram or anywhere. So for a social media influencer, if you can have some tool which gives you captioning according to your tone, your way of living, your lifestyle, and without, and ensuring that it does not get leaks on the cloud before posting it. So you want recommendation before posting it while maintaining the privacy. This is one of the pilots we done, and it really did really well in terms of generating the caption. So there could be enormous use cases in
So
personalized trainings.
yeah, just to like summarize, like it comes back to personalization, like anything that because of federated learning and because the hardware in general is getting better, you can do this locally on your devices. And this is something that we are super excited for because the number of use cases that we can enable here are numerous. And it's a generic model again. Like if I'm building my own SOAM's Copilot, Vignesh can also have its own. But at the very core, what SoraChain really enables is your model to learn from my model and other way around as well. So at the end, we learn peer to peer, and that's what models really need to do, is to understand your context, my context, without giving away the raw data on raw information, and still collaborate on the intelligence.
No, that makes a ton of sense to me. Actually, one question I have on that, and I think context kind of triggered this in me, is like there's inference, right? So there's the
Mhm.
training, but then context is also quite important, even for models that have been previously trained. And
Yeah.
context can severely be improved through private data. Is that something else that you all are looking into, or?
Yeah, that's exactly what we are enabling. Like if you see this from the personal scale, like an end user, if you can actually contribute to a training on your device on your data, and let's say you're training a small model on your device, you are training your model on your small device, that's exactly what we enable. And this is the local context, which could be fed into the global model, or it could be paired with, let's say, GPT or Anthropic. So as a GPT, it does not have local context, but if you let's say have an application layer, it takes the API from them, from GPT and from your local context, then you have the entire stretch of what you can do with it.
So imagine, like, we have different AI agents using multi-model capability. Now, since everything is on your device, so you have much more context when working for a specific output. So if there's an AI agent which wants to utilize multimodal capability or context from different use cases and then club it in one single line and give you an output, so by probably using our framework, they can do it much more efficient and much more better manner. So this is actually, indirectly we are increasing the context of the user while having the inference at scale also. Yeah.
Yeah, but that's one part, like we are locally improving the context. But at the very core, when the model is getting updated, even the local one is also learning from the other peers in the network. So the, the capability for a model to, let's say, be creative for some problems that you might want to solve is just going to increase because then it's learning from other humans as well.
Right. It's basically the other humans is like a network effect. The other humans get the
Exactly.
benefits from the training on the other
Exactly.
private data. They
Yeah.
get to train with their own data, and then they get to
Yeah.
feed in the context of their private data during the runtime execution with
Yeah.
all these privacy guarantees. And
Yeah.
so because of that, you can have more powerful models that can
Yeah.
having access to these more types of
Yeah.
sensitive data.
Yeah. And the best part of the is the local inference, right? Because I'm training my own model, I can just infer it for free. Like it's
Yeah.
on my device. Like I
So
yeah.
latency
So
is minimal, the cost is
yeah,
minimal, everything is
yeah.
minimal.
It's like running a local model, right? Like if you pick any of this existing open source local model running on your device, but those are uh, generic, and this is yours model, which could be coupled on the application layer with other existing big models to
Yeah,
make
that's
it work
awesome
in
to
any.
hear.
Yeah, yeah,
Okay, I have an idea, and you guys tell me whether it does or doesn't work. Like, let's imagine that I could upload like my DNA from 23andMe, my
yeah,
healthcare records, my
yeah,
my workouts from Apple
yeah,
Health, and
yeah,
like maybe some like food pictures of my food. Like,
yeah.
could I like is that one, is that possible? And two, could you guys like create like a AI like health personal trainer like kind of
Yeah,
thing?
yeah,
Because
yeah,
like that's actually very hard to
that's
combine all
exactly
that.
where we are going towards, right? And
Okay.
the thing I would change here is like you're not uploading your data, you're just
Yeah.
giving it the local access to the data. That's
Oh,
it.
I see.
Like you're not uploading it anywhere. You're just giving access to the local model on your device. That's it. Like you're not
Oh, okay.
uploading.
So you don't even have to upload it. You just maybe I download an app and then I give access to
Exactly.
my
Yeah, yeah, yeah. So data never moves. Data stays where it is. That's the fundamental.
and then the local model passes it to the other model. It gets to training and the
Model
updates.
just passes the weights and gradients after the training to the
Yeah.
global model, and which happens through the network. Like let's the 100 devices, they do the same, and then what we are doing is matching the state. So your global model state and your local model state would be same.
Okay.
Yeah.
That's awesome. And I think maybe next, let's just go a little bit more into what's next for kind of like the personalized intelligence and SoraChain in general. What's coming up on the 2026 roadmap that's got you all really excited?
Yeah, so first, we are looking forward to do a couple of good pilots at a good scale. So right now we know federated learning works. We know the trustlessness also works at let's say 5, 10 peers. What we want to see is if it really works at 100 peers or let's say 1,000 peers across the globe. And this is something that we want to experiment in next probably let's say 3 to 4 months and see if this really scales. And we are already having a couple of pilots for this, who we are going to do this with. So this is the first thing that we are going after, is to prove the trustless and the scale part for a smaller use case and make it clear that this really works. And at the very core, we want to open up the infrastructure by end of next year for anyone to come and spin off their own subnets. And the subnet structure is particularly to any vertical specific model. So healthcare would, let's say if you're having a very particular cancer research, you would probably have a very dedicated subnet for that. And if you're doing, let's say, fraud detection, it's a different vertical and a different network for that. So I think biggest problem is data heterogeneity. And for that the reason we are doing a subnet model in which you are completely different. So data, like there is no cross data problem there.
Yeah, and few of the verticals which we are very excited is one of it is like wearables, since
Mhm.
we feel that wearable is also going to be future. Like maybe it will be glasses, your watch, or maybe IoT sensors or anything. So that they actually keeps on working and collecting the data, and you can actually see through their eyes. Now you have meta glasses, you have different sort of glasses that might come in the future, and everyone will be wearing it. So, and to give them more personal experience using AI capabilities, so we are eyeing that vertical as well to give them more
And I
personalized
think it's
experience.
also the using another form factor for personalization is the key, because like with the smart classes, you actually get vision and audio as part of the data, and that actually it builds the depth for you in the personalization as the model trains, which you cannot really do it on your just with your smartphone data, because it does not really capture vision. Like it does not really know where you are and does not even listen. Maybe listen. Audio could be done with smartphone, but not the vision.
Well, I mean, I definitely wouldn't want my smartphone or any audio or video going without a lot of these guarantees, right? Like that.
Yeah,
I wouldn't want
yeah,
a model or any company having access to everything I can see every day or hear every day, right? Like
yeah,
I just
exactly. That stays local. But if you see most of the smartware glasses today, they are actually processing it on on the cloud. They are not processing on device on locally.
right. So that
Yeah.
it's awesome and really really excited to see kind of like what the next year brings for you guys. And to get some of these use cases like further along in Bootstrap. I think we're kind of almost approaching maybe like the end of the questions that I had. Do you guys have any questions for me? Any other points you wanted to hit on?
Yeah, I think a big question for me, like, where is EigenCompute heading? Like, what's your roadmap for the coming year? Is there anything that you think that we can still be a strong synergy upon?
Yeah, I think so. So our roadmap for 2026 is a couple of points. One, like so the way I think about EigenCompute is you're giving smart or like Docker containers similar guarantees to smart contracts. And so far we've given guarantees around what's the code that's running on the blocks, right? So we use like we actually just shipped verifiable builds so you can get like an attestation that this particular code was used to generate this particular Docker image, which is what runs on this particular box, right? But now we're going to tie in the EigenLayer stake a lot more.
Mhm.
And we're going to use that to do things like, hey, no one can just like turn off the box. For your use case, that isn't as powerful. That's more powerful for like if you have tokens on the box, right? Because you can just turn it
Mhm.
off. But we're also going to like leverage things like upgrade delay. So you can get guarantees that the cloud operator or anyone else can't just upgrade this thing and like, change it to push the data somewhere else, right? And then that I think is very useful for kind of this like clean room scenario. And then the next thing that I think is going to come is we want to have something like forced inclusion. So like someone who's a user of your system could force you to delete their data or any models or
Okay.
training or anything that had been uploaded to the EigenCompute box. So it's giving you a very powerful guarantee because you could know that if you put anything into the EigenCompute clean room, but like you know the code that touches it and you can force a delete so that so even if you moved some of that training and stuff on to that compute box or like there's some data there, you can get guarantees that like that data is never stored and you can always delete it.
Mhm.
So then that
Got
gives you um, a really good privacy guarantee because there'll be slashing with it, right? So then, like if someone violates that guarantee, if IGAN or anyone else, then they get slashed. Money is lost, et cetera, et cetera. Um, and then the other things we'll add is just like anyone can pay for the execution of the box if that's useful for you. That's more like so like if you have put tokens or something, maybe you're using your data and let's say it's 23andMe and they go bankrupt, you can still benefit from all the training you've done, even if like 23andMe or the company that you paid with went bankrupt, you can still pay to use it. We'll be also kind of stepping into more of a GA state, where we're kind of in the mainnet alpha right now, and then fully audited everything, etc. With that, and then from there, we might. I think that's a pretty good roadmap there, and then we're gonna like look at a bunch of other features and things like
Yeah.
even having maybe let's say like a database or something else that gives similar guarantees that I can compute.
Yeah, I think the ability to make models forget or the ability to just delete, I think that's a very crucial part of a lot of models, especially in sensitive domains. Let's say if we have genome data and if you really want to delete someone's data, you should be able to do that from the training. So yeah, I think that's a critical part where I see there is a need for a good stack and a good developer experience in general on how to make it more accessible across different development
Y-
environments.
Yeah, I think having a guarantee that you can delete someone's data and the user can actually believe and trust that,
Yeah,
I
exactly.
think that'll be really powerful because I
Yeah,
don't honestly think I believe or anyone really believes that when you delete you ask these other models to delete their data that it's actually deleted. And
yeah,
it's no
yeah, yeah. And even for us, like in even when we are using federated learning and data never leaves your device or your premise, like data stays where it is. There is still a problem that comes up is data memorization. Like if the model starts remembering about you And if the global model can, let's say, know about the local model, and if anyone can do inference on that, that is still a problem. So like maybe I think if there is an element to delete data or something which is coming up in the inference, so that could actually be super good for us to complete the entire feedback loop of the design.
Yeah, I think it'll be awesome, and it'll be really exciting to like partner with you guys on that
Yeah,
next year.
yeah,
And
yeah.
I guess like after the chat, we can we're super happy to talk more about that, and anyone
Sure.
listening, super happy to
Yeah,
collaborate
definitely.
on
Yeah,
those type of
yeah.
learnings.
Definitely.
So in general, we are super happy to be part of EigenCompute and just EigenLayer community. It has been really good, and your stack is quite powerful. Uh, that's what we really wanted. It really improved our timeline on just experimentation, fast iteration on what we were looking for. Yeah, that's perfect. Thank you.
Awesome. Well, thank both of you for being here. This is an awesome session where we really went into like kind of like how we can leverage. You guys are leveraging federated models and all these guarantees to like give models more powerful data while still giving users a lot of guarantees over like how that data is used, which I think are two
Yeah,
really important things in the age of AI. And I think for anyone listening, like please follow SoraChain_AI and Swayam's Bots and Blocks channel. To anything else that listeners to do to work with you guys or
yeah, that's great. I think you can just give us
okay.
a follow on our X, and that's a
Yeah.
good start.
Okay, awesome. Yeah, and then if you are interested in EigenCompute, just go to developers.eigencloud.xyz or give us a follow or give me a follow and ask any questions. We're here to help. Thank both of you. Thank you both for being here. This is an awesome session and excited to see what we can do next year.
Yeah, perfect.
Sure.
Thank you so
Thank
much,
you so much,
Vignesh.
Vignesh. Thank you so much. Yeah. Have a good
Thank
day.
you.
Yeah,
Thank you.
see ya.